All right, you guys. So let's look at, we're just going to continue this PowerPoint talking about fingerprints and fingerprint characteristics. Let me get this to a presentation mode here, just a second. Okay, there we go. So this is kind of where we left off last week, and I want to do a quick review for you. So looking at characteristics of fingerprints, forensic examiners look for several different characteristics. They look for cores of specific characteristics. They look for deltas, they look for ridge count, and the core being the center of a whirl or loop, the delta being a little triangular near a whirl or a loop, and then the ridge count is the number of ridges in between the center and the delta. So just as a review for that. All right, now moving on. So there's different types of fingerprints, and we talked about three main categories. You've got the whirl, the loop, and the arch. But now there's actually multiple types of whirls and two types of arches that we're going to talk about. So right here we have what we call a central pocket loop whirl. And as you can see, where's my mouse? There it is. Okay, so we got the core right here, and then you have two deltas, one closer to the center and one further away from the center. Okay. Then in the center here, we have what we call a double loop whirl. And this is a characteristic where you have kind of a loop right here, but then you also have a loop right here, and it makes almost a big S. And there's also two deltas to be located in this type of um, type of whirl. All right. And over here we have what's called an accidental whirl. And with this one, you actually have three deltas. Let me see if I can move my picture down just a bit so you can. Okay, there we go. And so this kind of makes almost like, to me, it looks like a bean type shape. And then you've got three deltas to find in this type of fingerprint. Okay. All right, now we have arches, and there's two types of arches. You have a plain arch. Again, an arch is where you come in from one side and go out the other side. And then a tented arch is simply a really steep arch. It's much steeper and actually kind of comes to a point. And with a tented arch, there is a clear delta that you can find in that. So there's plain arches and tented arches. All right. Moving on. If it'll let me. There we go. Okay. So basic patterns, you can further divide them into like the percent of the population. So with arch patterns, 4% of arches are plain arches and 1% are, 4% of the population have plain arches and 1% have tented arches. 2% of whirl patterns are central pockets, 4% double loops, 0.01% accidental loops. So if you have an accidental loop, you are super unique. Even twins have unique fingerprints. And if you guys want to talk to me about this later, there have been several cases throughout history where twins have been convicted of the other twin's crime because of fingerprints, and a lot of it has to do with the number of characteristics they're picking out, because twins' fingerprints are close but they're not exact. So identical twins specifically is what we're talking about, and it also depends on how identical they are. Identical twins have the same DNA, but depending on when that egg split, their characteristics are slightly more similar or less similar, and we can talk about that because the environment impacts DNA, and we're not talking about DNA in this class, but if you want to know more about that specifically, let me know. All right, so these right here, what we call fingerprint minutia patterns. And we're going to go through, you guys are going to need to be able to label each of these. But number one, we have what's called an ending ridge, okay? And so you've got two ridges, and then in between it, you've got a ridge that just stops. That's called an ending ridge. A fork or bifurcation is where you've got a ridge and then it splits into two, like tongs or something. We have island ridges, where you've got like just a little line in here in between two other ridge lines. Dots are basically like islands, but they're really short. Okay. Bridges is where you have a ridge that goes in between two other ridges. A spur or a hook is a little ridge that comes off and out. Then we have an eye, which that is where you have like a bubble in there of the ridges. Okay. A double bifurcation is where it breaks off once and then comes down and breaks off again. A delta is where it splits off like this, okay, and then you've got a little dot in there. And then a trifurcation is where it splits off into three different ridges, okay? So I would make sure, look through those, make sure you understand those. I will probably have you label those on several assignments, but then also when we get to the point of having like a quiz over this, it will be a take-home quiz, but you'll need to be able to identify these, okay? All right, so types of fingerprints. There are three types of prints that investigators look for at a crime scene. So they're going to look for patent fingerprints, which are visible prints transferred onto smooth surfaces by blood or other liquids, mostly blood because they're very, very visible. Then you have what we call plastic fingerprints, and these are indentations left in soft materials like clay or wax or dirt, but where that impression is left. And then we have what's called latent fingerprints, which are made visible by dusting with powders or use of chemicals. Latent fingerprints are what typically we think of when you think of a crime show and they're lifting fingerprints. Those are the fingerprints where you add chemicals, they become visible, they're everywhere. Okay, people, you leave your fingerprints anywhere your fingers touch. The latent fingerprints are what we're talking about when they're lifting prints like that. Okay. So, how are latent fingerprints collected? These are several different chemicals they use. They use anhydrine, cyanocrylate vapor, silver nitrate, and iodine fuming. I actually have a video where we will talk about the use of glue at some point. So anhydrine is used on paper objects, and you dip or spray the anhydride. You wait 24 hours, and it comes up with a purple or blue print. The cyanocrylate or acrylate vapor is used for household items, plastic, metal, glass, skin. And you heat the sample in a vapor tent and a white print appears. If you use silver nitrate, you use that on wood or styrofoam. The object is dipped or sprayed in the silver nitrate and then a black or a reddish print appears. And then you can do what's called iodine fuming. That's used on paper, cardboard, or unpainted surfaces. You use a vapor tent and you heat the solid iodine crystals and then a brownish print will appear. However, you have to spray with a solution of starch. So it says that right there in the table for you. Okay. Can fingerprints be erased? Only temporarily because they will grow back if removed with chemicals. Is fingerprint identification reliable? Yes, but analysts make mistakes. And we watched a video about that where they misidentified the guy for the Paris bombing because they didn't look at enough. They didn't have enough of those identification markers. Can computers perform matches in seconds? No, they can't. So when we watch our wonderful FBI shows and CSI shows, they'll put a fingerprint into APHIS and it is like automatic, right? It's like doo-doo-doo, and then they have the match. That is not how it works. Usually takes up to 2 hours. If the fingerprints are in there. If the fingerprints aren't in there, right, then it would take a lot longer, if not be impossible. So the future of fingerprinting. There's a lot of new scanning technologies. They yield detail in minute patterns, reduce analytical mistakes, analyze trace elements of objects on the skin. Analyzing these trace elements of objects on the skin. I'm going to post a video probably today as well, where I'm going to have you guys watch, and it has to do with identifying molecular markers that can be used to actually identify fingerprints or to make a fingerprint appear where it wouldn't have, or it didn't otherwise. Technologies that recognize patterns in retina, face, and veins on your palm are becoming really popular for security devices. Again, using the same principle of individual patterns on each person. Okay, so In summary, fingerprints have long been used for identification and in the mid 1800s were recognized as unique to each person. Three main groups include arches, whorls, and loops. Basic analysis includes looking for cores and deltas and making ridge counts. Investigators search for patent, plastic, and latent fingerprints. Dusting with powders or using special chemicals can make latent fingerprints visible. New developments may eliminate errors by analysts. All right, you guys, I hope you enjoyed that PowerPoint. I'll be posting an assignment for you guys to work on and then another video that I want you to watch for the remainder of this week. I hope you guys have a great day.